Thanks everyone for coming. And AppNexus for hosting. Can everybody hear me okay? Great. Well, I can see my screen and now I can't see you, so I guess that's ideal. I want to start by seeing where everybody is at. One of the challenges as Clojure grows is I'm no longer talking to people who know absolutely nothing about it or other things. So how many people use Clojure at work? Okay. How many people have tried Datomic in any form? How many people have used Datomic Cloud? Oh, okay, cool. How many people have never heard of Datomic or don't really know anything about it? Not too many. I won't spend too much time on Datomic first principles. I'll try to get into the Ions part, which is where I'm here. And how many people are on the cloud? Their apps are on the cloud, hosted on AWS or Google or something like that. How many people are not? How many people are opposed to the cloud? No, it's a thing. All right. Okay, good. All right. So let's talk about Datomic a little bit. And so on each of these things, I think I tried to say what the problem was that we're trying to solve. So with Datomic, we're trying to solve the problem of databases are a source of complexity at the system level, right? They're the big, giant global variable that's in the middle of your system, and it doesn't matter if you're using a functional programming language or languages all around it. You have this problem with traditional databases that you can't reason about them. So Datomic is pointed at that sort of most generally. And the idea behind Datomic was to give you as a programmer a view of the database as a value or as a succession of values so that over time you can look at any value of the database at a point in time. And to break away from this database as a place. And this is super important. I mean, it is fundamentally simpler in the, trademark simple way. And it is so because you can start to understand how your database got to be the way it is. When you just have places, you discover, some, squirrel in your cupboard, and, it's like, who put that there? Well, 50 transactions ago, something happened. So we want simpler systems so we can think about them. There's a lot to the Datomic information model, and I'm not going to talk about it at all today except to run through these O's. Right? So it's simple. It's transactional. So we do have transactions. It's flexible, and that goes somewhat to the way we represent information. I'll talk about that in a second. It also supports hierarchical data well. It's indelible, so we don't forget anything. We keep everything that you ever said, unless you explicitly go out of your way to tell us to remove it. It's chronological in that it has a notion of the time things happened in the database. And it supports queries. So it has all these O's. I would also say I left out here that an important part of Datomic is that it's programmable, that it uses data structures in the way we tend to do in Clojure so that you can write a program that writes a query or write a program that generates a transaction. The kind of programmability is really big. The one O it doesn't have is SQL. And I think if that's driving your choices, if you need compatibility with that, I mean, Datomic is just not going to do that for you. It ends up that it is a relational system, but it doesn't have the SQL language. So it's a relational system, but it has essentially one relation, EAVT, entity, attribute, value, and time. If you ever work with RDF or anything like that, there are triples. So this is like triples plus time. And in this way, you can have different versions of facts over time. So, today you like pizza, tomorrow you like ice cream. And you can switch between those two, but it doesn't change the fact that today you like pizza. And I think an important aspect of the universal relation, which again is about building loosely coupled systems, is that it makes for loosely coupled systems because you do not marry the definitions of tables. I think that one of the things we have going for us in Clojure, and it's a value proposition that's carried over in Datomic is that when you say, X, Y, and Z go together and it's called foo, and the only way to really talk about X, Y, or Z is to go via foo, and here foo would be maybe the definition of a table in a traditional database. That mapping, that's saying, well, I know where X is, it's in foo, is something that's introducing some brittleness into your system. You have a sense of where things are, even if it's not an update in place database. The idea of tables being a kind of a place introduces a kind of coupling in your system. So I really do not like coupling. And so we're trying to reduce that here. But getting a sensibility around seeing that, I think, is important to really sort of appreciate Datomic. And then, a big value proposition of this universal relation is it's flexible. Right? If you have sparse data or hierarchical data, you want to have something that's a member of something else that has many things. These are not complicated. They don't involve the creation of an intersection record or anything like that. And I think as Clojure people, we maybe take all this for granted now, this kind of stuff, but it's not common. I would also contrast Datomic with document stores where they sort of will tell this story about being sparse and hierarchical and things like that, but they have that same marriage of structure that tables have. In other words, if you need to know that this thing is in this document, under this, under that, and that's where we kept it, that's another kind of place, and that introduces brittleness in your system. In Datomic, we can form those trees. You can just pull up on any point in the graph and get a tree that looks like that, but you could pull up on a different point in the graph and get a different tree. You haven't married a particular organization. So we want that, and that makes for flexible systems. The last part, which is going to carry through the rest of the talk, is one of the things I was trying to accomplish with the design of Datomic was to get more leverage out of immutability. Datomic is a big, very big persistent data structure that's actually durable. So it's persistent in the way the Clojure data structures are in memory. And it's also persistent in being durable, enduring on storage. And I mean that in the same way Clojure data structures are, in that it's immutable, for reals. It's not as if it was immutable. Because it's immutable for real, it means that you can relentlessly copy stuff around. You can take nodes in this big tree, and it's a persistent data structure like the ones in Clojure in memory. It's a big tree of nodes, all of which will never, ever be changed again. And that means that you can freely make copies of them, and they don't need to be coordinated. They'll never be changed. There's no coordination necessary to deal with updates, because updating doesn't happen. That means that you can move the data around, you can get it to different places, and therefore you can locate things like Cori in different places with a lot less coordination than is incurred when you try to set up a traditional database with a replication strategy. We're actually sending the changes around and trying to stay in sync with changes. That's the gist of Datomic. What is the cloud about? I didn't write the cloud, so I'm speaking for other people. I hate that phrase, the cloud. It sounds like a superhero, like a not very good superhero. Like, oh, the clouds. Do we need to worry about that? Doesn't sound right. And so, there are a lot of attributes, but if you're trying to say what problem is it trying to solve, the problem it's trying to solve is, who cares about this stuff? Who wants to run machines and figure out if they're working and switch out network cards and deal with hackers and blah, 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 blah. That's not most people's business. It is some people's business to do that. When I say it's not a core concern, I don't mean that you don't care about it. I mean, it's not what you're about. Your organization is not about this thing. How many people have ever been somewhere where you were dominated by keeping your infrastructure going? That was a big part of your life. Yeah, and it's not what the company's trying to do. Also, there are, I don't want to buy computers anymore. I don't want to run data centers. There's a bunch of that. But I think this is the big point. Right? This isn't what your company or organization is about. Therefore, let's go to somebody who can provide it as a utility. So there's infrastructure as a service. I think it can do better at reliability and security than most people can do for themselves. Obviously, there are big shops with a lot of expertise who can do great things. I'm not trying to diss your personal expertise. But most people are better off letting somebody else do it. Just like they're better off letting somebody else, generate power. Other characteristics that are useful is that you pay for what you use. You tend to pay for what you use. There are obviously lots of flavors out there. This idea of more utility consumption is a big thing. Another thing that's a sharp contrast to do-it-yourself with actual pieces of hardware is this notion of on-demand provisioning. How many people ever worked at a big company where if you wanted a new computer, you had to fill out a form and wait months and months and months? This is not like that, right? This is just saying, give me more computer. You just ask for it and you get it. And I think that works in multiple directions, at least depending on how auto-scaling works in the cloud that you're in. This notion of getting stuff on demand and getting more of it when you need it and actually getting rid of it when you don't need it, I would characterize it as being elastic. It's also an important characteristic and something, a value prop of the cloud you want to pursue. Overall, the idea here is that you have a lot of flexibility. Before, anything you wanted, you had to commit to. You want new computers? Great. Decide right now what kind of computer you want to have for the next 5 years, because I'm not getting you another one for 5 more years. Decide on what kind of network cards you want, and decide. Now you can sort of put things together, try them out, resize things, experiment with new technology as new services come on. You can take them on and try to use them. And that increases your flexibility. But again, sort of a theme of this talk will be, by having this, you're able to focus more on the actual problems of your organization, the business you're trying to run, the things you're trying to do. So I'm a fan. I don't think it's perfect. But I think this is, again, as inevitable as the transition from creating your own power to having utilities for that. Of course, then Google and Amazon generate their own power, right? So it goes around in circles. All right. So we had Datomic. Datomic was something that you could run on your own behalf. It had a very traditional, it's not something that's gone away. It's now called Datomic on-prem. For running on your own behalf, it has a traditional kind of licensing model. With Datomic Cloud, I think we're trying to accomplish some more things, more than we could do by giving you software to run on your own behalf. And if I had to, again, sort of boil it down, so what problem are we trying to solve? We're trying to solve the problem of maximizing your leverage. Right? If we could give you deep integration with the platform, can we maximize the amount of leverage you would get from having done that? Because there's a sense in which when we give you software to run on your own behalf, it's sort of the end of our ability to help you. Right now you have to go, well, maybe you have to go ask for a machine and wait 3 months so you can run it out somewhere. I hope not. But even if you chose to run it on a cloud, it's still kind of software that doesn't necessarily know that you're doing that. I mean, we always supported cloud storages like DynamoDB, but there's a limit to how much we can help you. And here the idea is, if we made a version of Datomic that was deeply integrated and knew where it was running, how much more leverage could we give you as users? We'll see that gives you benefits in Datomic itself, and then this new benefit, which is Ions. So what is it exactly? It's Datomic running on AWS. Not a multi-cloud thing. It's about AWS. It's about deep integration with AWS. It's available on Marketplace. So you go to Marketplace, and the way you shop for databases, don't you just go on the web and say, I want a database, and you read some descriptions, and then you click. Apparently, in Marketplace, they think that's what you do, but that's where it is. And it is that simple if you've decided either from reading our amazing description or from hearing about it somewhere else that it's something you want. You click a button and fill out a very minimal amount of stuff, and you get a Datomic system running on AWS. But again, sort of the emphasis here is on leverage. So how many people have run stuff on the cloud that they used to run on their data center? So that phase of cloud adoption is called lift and shift. Right? It's like somebody tells you, we're closing the data center. Get all your software on the cloud by next Tuesday. And you're like, oh my God. And I think what happens then is you look at the cloud as a bunch of computers that you don't own and some networking stuff that you don't own. But essentially, you're thinking about it as this virtualization of what you used to run on your own behalf. And that's sort of like the first tier of cloud embracing. And it's unfortunate because a lot of people do that and they end up with a terrible experience. They end up hating the cloud and being like, well, A, this doesn't work very well, and B, it's more expensive. If I was running my own computers, it would have cost me less. And a lot of people had that experience with the cloud, and they're still having it. And it's because there's this misfit. Right? You're taking data center software. What does data center software think? It thinks that you have what we call pet computers. A computer that you could name. Anybody have computers and they have like little stickers on them? It says the name of the computer. Fred's computer, or has an IP address on a little sticker on the label. And when it doesn't work, you can walk over to it and you can whack it on the side, right? And when the memory's fried, you can pull it out and you can touch it, and you put another one in, and you can fix hard drives, and you can touch all these things. So data center software thinks you actually have hard drives that don't vanish. You have computers that don't go away. You have IP addresses that don't randomly change. They expect this sort of enduring nature and identity to things that don't exist in the cloud. So you get up on the cloud and now it's a struggle because there's really no such thing as a hard disk that you can trust will be there tomorrow. Or if there's a virtualization of that, has a lot of intricacies to it, like EBS and trying to create bindings to EBS and make sure that they don't get orphaned. So there's lift and shift. I don't consider that a source of leverage. That's just a source of switching your cost basis around. And there's also sort of cloud neutral approaches. I don't want to buy into, and maybe the flip side is, I don't want to be beholden to a particular provider. Let me go and make something that will work anywhere. Again, I think you have reduced leverage from that. But we're saying we want leverage by embracing AWS as if it was sort of a cloud operating system that provided a rich set of facilities. We don't want to abstract away from that. We want to directly target it. So there's a whole bunch of stuff you get by being there, right? AWS has, I think, unquestionably the richest set of offerings and services around what you need. There's VPC for security. There's IAM to manage access. There's encryption at rest with key management services. We utilize all this stuff in cloud. We set it up automatically. We configure it. It's running. We build a VPC. We use IAM to manage access. Instances are running in roles. All that stuff you want from AWS, we're directly using. We encrypt the data at rest with KMS, and you can see the keys and the use and everything you would expect. The Datomic Cloud install will set up all the networking for you, and I'll show you a picture of this in a second. So all the routes are set up, and Route 53 is set up, and the security groups are made. You end up with a simple endpoint you can connect to that's enduring. We'll set up a network load balancer in some of the topologies and get that all running. And here, I think, is where you really start to diverge from data center software. Right? How many people had data center software that when the software got busy, a computer magically appeared and helped out? Like in the rack, boom, there's a new computer. Anybody have that? No, that's not a thing. And it's a very big thing in the cloud. A couple of years ago, and it's a long time ago now, I was at the big AWS thing in Vegas, and now I'm not sure if it was the CTO of Pepsi or Coke. Crisis. But she was up on stage and she was saying, I'm tired of running, effectively, I'm tired of running data center software. I want software that can auto-scale. Right? Because if you have data center software, well, it was written to run where there was a rack, You couldn't just say, give me a new computer in the rack. But in the cloud, you can, and so you want software that understands that that's a possible thing and knows how to scale automatically. And in particular, to scale up and down triggered by load. So the Datomic Cloud does that. There are a very rich set of storage systems, subsystems available on AWS, and they vary in how much redundancy they provide, how much reliability they provide, what kind of latencies they have, and things like that. And Datomic Cloud uses all of these things, DynamoDB, SSDs, the Elastic File System, and S3 to form sort of a hierarchical stratification of caching and long-term storage automatically, as well as building in distributed caching in the nodes. And then the other thing you expect from running in Marketplace is that you have per instance hour pricing. So we just mark up the instance hours, and you pay for it like you pay for EC2 instances. Which means it's a little bit like Clojure. Everybody remember sneaking in Clojure? How that worked? It's just like, it's just a Java library. Right? So this is just like, it's just this line on the EC2, on the AWS bill. And that's how it works. It's just part of your AWS bill. So the emphasis here is on getting leverage from AWS by knowing about AWS. I mean, we're marrying all of this tech, and it means that you get the advantages of using all of that, and you don't necessarily have to. I don't want to go here yet. You have to get involved in that, knowing about it. So another principle here is that you can start small and grow with cloud. So we have something called Solo, which you can run for as little as roughly $1 a day, and get started there, and then eventually move to a production topology, which allows you to scale in various ways. I'm just going to quickly let you see what they look like. So when you go to Marketplace and you say, I feel like getting a new database today, and you push the button, give me Datomic. In the Solo configuration, we make all of this. So you just push the button and say, start it, and you get a VPC made, you get a Dynamo table made, you get a S3 bucket created, you get an Elastic File System created and mounted, and all the mounted nodes available in all the availability zones of your VPC. You get a single node, that's why it's called Solo. It's running in an auto-scaling group, but the auto-scaling group's job is to keep it alive as opposed to scale it out to more than one. It's basically one at a time. We set up a Route 53 hosted zone, and we point it at this node. We also keep it updated if you do have the node cycle for any reason. And this looks to you like a single CloudFormation stack has started all this. It ends up being a master template that has two independent stacks, one for the storage, one for the top here, which we call the compute. In addition, we start a Bastion node there, which is designed to provide access from outside the VPC. So we never expose your Datomic Cloud nodes outside the VPC. Never. So there's a Bastion, and we provide you the tools so that the client that you embed in your Clojure app can talk to a SOX proxy, and get in through SSH, and eventually talk to the system. This is the tiniest thing. This is the $1 a day thing. It's a huge amount of stuff you don't have to start or operate. And this gives you a functioning Datomic system with a lot of reliability. It doesn't have high availability because it's just one node. But it's a great way to develop, build your ideas, try things out. And it is pay as you go. So if you just want to try it for a couple of hours, you can do that. When you're ready to try to do things at scale and have a reliable system that's highly available, you can push the other button or make the other choice in the dropdown, which is the production topology. That starts the left side of this. The right side of this, optional. It's actually a secondary stack. And here you get the same storage infrastructure. And in fact, if you were running Solo and you transition to production, you can just use the storage that's already there, and the databases you've created, all that stuff will just work. You still have a Bastion. There is still a Route 53 thing. I took it off this picture because it just gets crazy. But the important thing here is that now there's a network load balancer in play, and you're going to have more than one node. In addition, these nodes have SSDs on them, which forms the near cache. So the way Datomic Cloud works is that your logs and your live transactions are going right into Dynamo, which is the lowest latency system they provide. And it has the CAS semantics we need. And then as indexing happens, those big trees of immutable stuff I was talking about, they get put in S3. They redundantly get put in EFS. And that's so that when you get cache failures higher up, you have a lower latency thing to back up to than S3, which is pretty high latency, but very high reliability. And then there's a near cache. So every node has got essentially the tree cached again on an SSD on the same box. So most reads don't go over the network at all. This is a great system, and this is really, this is the value prop of immutability. There's nothing to this. There's no fancy coordination required or anything else. We just build a big, we call it the sandwich. Build a big sandwich of caches, and they all read, repair through, and you get data all the way up, all the way nearby, which means that queries are getting satisfied from data that's on the box. On the right, you see query groups. Again, they get started by different stacks. I'll talk about them later. So this is sort of what's happening. Those diagrams are nowhere near all the stuff. There's a ton of stuff. We're also creating IAM roles, auto-scaling groups, CloudWatch dashboards, permission sets, hosted zone. We create key management keys. I talked about the Dynamo table, the internet gateway necessary to talk to other services, and the network load balancer. So we're doing all this stuff, and Datomic Cloud is all happy, and you're getting, essentially this instant database that's integrated. But if you look at this prior diagram, I had these hexagons that say client. What is that? The client's actually the thing you put in your app, in your Clojure code. And that's the API you use to program against Datomic. So this is a remote API. Right? So you get a client, connect to a Datomic instance, and you talk to the instances. The problem is, or a problem is, I say if the client's in the VPC, you can connect here. But the whole client in the VPC, that's a problem. That's your problem, right? Because your Clojure code is not in the cloud yet. Where are you going to run it? How are you going to get it to autoscale? How are you going to secure it? What VPC is it going to run in? What security group is it going to run in? Are you going to access that security group from other security groups? What role is it going to have? What permissions does that role need? And that's just sort of a fact of building for the cloud. And so, there was this idea of, you can focus on, what did I say earlier about the cloud? You can focus on your business problem. How many people on the cloud think that they don't need to think about the cloud and they're focusing on the business problem? No, they're all learning. You're learning all these things, right? This is a huge amount of stuff you have to know to do this well. So the idea behind Ions is if we could get your app to run on our nodes, you could sort of live in this nice nest that we made inside AWS and get a free ride and many other benefits. So that's sort of the core idea behind Ions. That's a little bit about cloud. So what are Ions? Well, now we're actually going to try to let you focus on your application. Right? Because running in the cloud doesn't let you focus inherently. I mean, you don't need to buy computers and deal with wires, but you still have to provision things, get them to scale, getting auto, all those things configured correctly. So could we let you, this is the problem again, could we let you really focus on your application, take advantage of the work we did in building cloud, and host your application on those nodes, that you're not running anything else. If you're running Datomic Cloud, that's all you're running, and your application code runs on it, scales with it, et cetera, et cetera. That's the fundamental idea. Run your app on the Datomic Cloud nodes. Right? And so I think it's important to sort of talk about your app. Now, Stu has talked about Ions before, and he said one of the problems was people didn't really get that when we say run your app, we mean like all of your app code. There won't be any clients. your app code will be on the Datomic Cloud nodes only. He said I should jump up and down when I said that, which I'm not going to do. But let's talk about your apps. So if you build apps for the cloud, what are they mostly? Many people build web services. Right? Some way of thinking about what you're doing is some service, right? You're some service, someone's going to ask you for stuff, you're going to give them some answers. Right? The other thing I think happens in the cloud, and it's happening a lot more now on AWS with Lambda and some of the other infrastructure for that, is you build event handlers. Right? Something happens in my infrastructure or elsewhere in my bigger system, and I need to respond to that. I do that in a reactive kind of way. I'm just going to get an event notification. So how many people do that kind of stuff, get notifications? On queues, SNS, something appeared in your S3 bucket, things like that. And the other flavor of app we have is sort of like both the supportive code for those kinds of edge jobs, right? This is the edge of your system, answering questions on the web or responding to events. And internally, you have app code both to support those things, and also something Datomic has always allowed is sort of the extension of Datomic itself by integrating code of your own into queries. You can call Clojure code in queries and in transaction functions. All of that is what I mean when I say your app. All right. So what do we get in terms of leverage from the cloud cluster? Well, that big picture, you don't have to do any of that. That's the biggest thing. The AWS setup and the topology of that, the auto-scaling groups and the scaling, triggering, the dashboards and all that is all wired up. In addition, you can generate your own metrics. We have an API for adding your own metrics and logging messages from your app. So you can extend what we've done, and that will appear in your dashboards. You get compute resources, right? So there was this question before, right here, where is your Clojure code going to run? Like, do you have to have an instance? Do you have to have Elastic Beanstalk or another thing? And the answer is no. You're going to use the compute resources of the Datomic Cloud cluster. And then the other big leverage point here is data locality. How many people use Datomic on-prem? It had peers. Yeah, so what's a big feature of peers? The big feature of peers is you query it, it feels like you're querying right in your app. Right? And there's a sense in which Datomic Ions are sort of an inversion of that. And when I first gave the Datomic talks, I said, everybody gets a brain. And we give you have your app, and we give you a brain, which is the query engine to run with your code. And now we just sort of invert that, and we say, we'll have this, the brains are in the cluster, you give us your thoughts. Give us your Clojure code, and we will think about it. In both cases, you end up with your thoughts and the caching of the database and the query technology of the database in the same process. And that's a source of a lot of power and performance. And it lets you do things with databases that you just didn't think you could before. I talked about a bunch of these things, right? Extending Datomic with your own logic. And this notion of sort of connecting to the broader AWS cloud, that idea of events. And we used Lambda for that. How many people have tried AWS Lambda? Yeah. So the way I think about Lambda is twofold. I think there are two aspects to it. One is sort of like this fine-grained compute and deployment infrastructure. Right? Make a function, include all of Maven with it, put it somewhere, then it can run on demand in a little bit of computational resource that will be allocated. You don't need to think about it. That doesn't resonate a lot with me. I think there are definitely use cases for that, especially if you have extremely rarely running programs that respond to events and things like that. But once you're running all the time, kind of old school about wanting that locality, that caching, that sense of, I am running all the time. I want the power from doing that. But there's the other aspect of Lambda, which is and the way I like to think about it, and the way we use it in Datomic. I'm going to show you Lambdas. We never do anything in the Lambdas. There's no code running in the Lambdas. We use it, and this is the other idea behind Lambda, as connective tissue. Right? AWS has said, oh, you're interested in doing something when somebody puts something in your S3 bucket? You write a Lambda, and we have the way in S3 to go and say, when somebody puts something here, call this Lambda. And that's a bit of connective tissue. It has actually nothing to do with the Lambda doing the calculation. It has to do with, there's a way to say, when an event happens, do this thing. The path from an event to something happening. And that's how we use Lambdas, as connective tissue. But it's present. I mean, there are many, many AWS technologies and services now that can generate Lambda events that your applications can respond to. This lets you build an application that's loosely coupled, that reacts to things without having to have a lot of polling and things like that. But it's a lot of power there. The other thing we already talked about is making web apps and web services. And the way we do that is by connecting through the API gateway. API gateway is a great idea. It basically says, let's take the idea of web serving and break it into two parts. Dealing with the internet and taking a request and generating a response. Okay? We'll let AWS deal with the internet. Right? Authentication, denial of service attacks, blah, 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 blah. Who wants to deal with the internet? Who wants to put their server on the internet? Not me. Right? So that's a great, decomplecting, right? Web serving has two jobs. Being on the internet and taking a request and generating a response. Now, what do we know about taking a request and generating a response where the request and response are data? Clojure is awesome at that. Right? That's what Clojure is for. That's like Clojure's reason to exist. So this is a great separation of concerns. So API Gateway allows you to set up an endpoint, expose it on the internet. You can bind it to your DNS stuff and things like that. You can do authentication a gazillion ways. You can do all kinds of transformations related to RESTful stuff, which I don't really believe in, but it can do that. But it's really good. So that's how you're going to expose your service with Gateway, and you're going to focus on writing a handler. The other big thing about this is that by sitting in this nest, you're in an auto-scaling group, which is automatically scaling depending on triggers you can hook up to various metrics we produce, which include, how busy are you? When Datomic scales, it means your app scales. There'll be more resources for both your application and Datomic. So you're already ready to scale elastically. And the net result of this is that you become much more agile. This is what you want. This is what you imagine the cloud would be until you saw, like, oh, there's 100 services and each one has 100 pages of documentation. So in the end, when we talk about sort of what is your application, right? We have web services. What do they look like after you don't have to deal with the internet anymore? You get an HTTP request, you have an HTTP response. Right? Ring, pedestal, all the Clojure stuff for doing that. That's how we do it. We already know how to turn it, from nasty Java servlets into data and back. That's just a function, right? Web service is just a function. Event handlers similarly are like that. Now, usually maybe they have effects, and so could web services. Let me put something in your S3 thing. Well, maybe that's going to cause you to transact something against the database. Process that input and make a transaction. But the inputs to the event handlers are straight JSON payloads. And then we have database extensions, right? Query functions are functions. They take arguments, they return data. Transaction functions are the same thing. You have to return transaction data. They're like macros for transactions. So when you get rid of all the cloud infrastructure and AWS stuff, the focus part comes down to writing functions. All these things are functions. If you could just write Clojure code that did these fundamental operations, Ions would take care of the rest. That's the idea. So the idea is we're trying to get that circle inside here. So how does that manifest itself? How do you do it? Right, so the first thing to understand is that there's no extra thing here. When you run Datomic Cloud, it's ready to do Datomic Ions. All the support, all the things I show you here that have to do with code deploy, and all of that, target groups and whatnot, that also got set up. I didn't put it on this picture because I would ruin the surprise. But more stuff, 10 more little icons are also being done in support of ions. And that's ready to go when you start a cloud system. It's ready to run. So before I get into like the steps, which are small and easily understood, I hope, I just want to talk a little bit about tools depths. So a prerequisite of developing for ions is that you've got a Clojure app, you're keeping it in Git, and you're using tools depths to do dependencies. This is not because I hate line again or boot or anything else. I think that the Clojure community hasn't completely gotten their heads around tools depths, but it's actually a simple premise, and the idea is I want something that only does depths. I don't want two things. I don't want a build system. I don't want two things combined. And invariably, dependency systems, because the build system needs to know about the dependencies, they all turn into build systems. And I think in doing that, then they say, well, other people might want to know about the dependencies. And so therefore, the way to do that is to have plugins. That whole thing just is too tightly coupled for my taste. The idea behind tools depths is dependencies a la carte. And I think what you're going to see in the way Datomic works, the way ions work, is an example of a consuming app. They're not special to Datomic. You know, Stu worked on the tools depths integration for Datomic Ions, and he was a consumer of tools depths, trying to use the tools to get dependency information necessary to do the job we want to do, without having to add it into tools depths or make tools depths pluggable. Right? What we want is something that's composable. Now, it ends up tools depths didn't do everything the way we would have liked, and working on ions has improved tools depths' ability to be used by other people for similar jobs in an a la carte way by composing processes as opposed to this sort of nested dolls approach to plugins. So I think tools depths are very important, and the ideas behind tools depths are important. You know, I designed it, and I really believe in it. So if you have any questions about like tools depths is like this weird thing or whatever, Alex Miller was off, imagining something. It's not. This is a mission critical thing for Clojure to get this right, to get this separate. And I think there are many other benefits, and I'm sure that we could have talks about that. But you got to do tools depths. Okay, so the first thing you have to do is you have to develop. Right? This is like writing software. We said we want to just write a function that says, if I get this payload as a HTTP request, this is what the response should be. I just want to write that function. So I'm going to have code in Git. I'm going to have dependencies. Another problem I wanted to solve, both with tools depths and with Datomic Ions, is the problem of sibling dependencies. Many people work in a shop that have broken up their giant app into different libraries. Many people have, I hope. This is yes, this is desirable. But then, what do you run into? You run into everything in Maven must be an artifact, and like you can't have this halfway done and that halfway done, and this depend on that because you have to deploy a halfway thing, and then you have latest or whatever the Mavenisms are there. I think that's a disaster. I think that needing to have artifacts runs contrary to being able to be agile about working on more than one thing at a time, and it actually thwarts the idea of it would be good if we separated these things and reused them as libraries. Many people have heard of the evil beast called monorepo. Yeah, monorepo is a football term for that. It's called punting, right? And I understand why people are driven there because like Maven doesn't help you with this. But it doesn't have to be this way. Tools depths is not like this, and ions are not like that. So you can be working on more than one library at a time, and they can all be halfway finished, and they can be on your machine only, and you can deploy them. You can't deploy them in a way that's repeatable, and you can't deploy them with an identity that would confuse anybody else about oh, I can use this thing that was just on your machine. But you should be able to deploy that and try it. How else are you supposed to interactively work? So let's look at this. Pictures. This is what development is like. Right? You're working on your machine. You have a bunch of functions in your Git repo in your application. You have dependencies and tools, in a deps.eden file. The dependencies are on your machine. They may be in M2 as proper artifacts, or they may be local deps. That's okay. The one additional thing we're going to ask you for is a config file, ionconfig.eden file, which describes some things about your ion deployment. This stuff is not getting jammed into your deps.eden. If deps.eden is not like this dumping ground. That's for deps. This is not deps. So there's another file. No, there's nothing wrong with that. I don't know why everything has to go in one file. So there's one extra file. And you do your ordinary stuff. You write and you commit. Right? Then you're going to push. So here it starts to get interesting, right? So you worked on something locally. You commit to Git. That's in your local Git. And obviously you can, when I say push here, I'm talking about ions push. You're going to have a library that will be in your devtime tools deps alias. That is the ion tooling. And the ion tooling has an operation called push. This lets you push your application into your Datomic cluster. So where is that? You have stuff on your machine. You have dependencies, which are artifacts and/or directories. You have your Git stuff, your functions and Clojure files, and you have a config. What push does is it puts that stuff in S3. Right? There's a place in S3 associated with your Datomic Cloud configuration that we use to put your deployments. This is just an application revision. It's not running anywhere. Pushing it just says, put it somewhere so I could run it somewhere else. Something else happens in addition to putting the stuff out in S3 is that we create a revision in code deploy. So how many people have tried code deploy? How many people know what code deploy is? All right, I'm going to talk a little bit more about code deploy because it's cool. So there are lots of different ways to get stuff running in AWS. How many people, for instance, make AMIs and restart EC2 instances? They burn AMIs some way. Not too many anymore. How many people make Docker images and then use something that puts Docker images on new EC2 instances? How many people in general start new instances of EC2 to get new application code running? It's pretty common, but it's expensive, right? An EC2 instance cycle time can be minutes to get new instances up. Code deploy is a way to get code running on EC2 instances that are already running. So the idea behind code deploy is you set up an auto-scaling group, and there's a bunch of EC2 instances, and they're all running the code deploy daemon on the boxes. What code deploy does is it lets a target group, which would be a particular auto-scaling group, that's a target of a deployment, to know that there is a new revision that it should be running. And they'll go and grab it. Before we get to that, and I'll show you that in detail later, the fundamental idea is that a code deploy application is a thing in AWS. You're going to have an application, it's going to have a name. So imagine you have your Datomic system you set up, and you're going to have an application called My Web App, My Web Service, right? When you make your Datomic Cloud instance, we will make a code deploy application called My Web Service. Not running anywhere, it's just a place where you can put revisions. So when you push, we will make a new revision in code deploy. If you go to the console and look at your code deploy, and your application will say, oh, there's this revision, and if it's a repeatable revision, it will have like the git commit SHA. You can run this, it corresponds to this version of the code. That's the first thing we'll talk about that's connected to Git. The revisions are connected to Git commits. That's the identity. I hate human made up. Version 2, like what does that mean? Version 2.3. Oh, that's better. Or is it better? I don't mean, these things mean nothing, right? And I think that one of the problems with the artifact system that I have with it is detachment from source truth. And we start, well, and it's old. I mean, I'm not saying that people got it wrong, but Maven, I think, predates Git, and artifacts certainly do. And the idea of 1.2 and 1.3 absolutely do. But now who is not using Git for revision control? And we're using Git. Git has a bunch of great properties as Clojure programmers. We don't need to have them explained, right? So we connect application revisions to Git identity. If you ever were wondering what version of the code is this actually that's running, there's no question it's the name of the revision. But what if you had local deps? What if you were in the middle of two different things? We're going to force you to create a human readable name that's going to go in a different place with a prefix that says unreproducible. So let's say unreproducible, Rich's latest brainstorm will be the name of that revision. And hopefully no one will look at that and say, that should go in production. So we make that. The important thing about push is we're not running the code anywhere. We've given it an identity. We've made the bits available in sort of a neutral territory, this S3 bucket. That's what's happening during push. Now you're going to deploy. And here, things get very interesting because the idea behind deploy is that you're going to take a revision and say, I'd like to see this revision running in this place, on this target group. And it ends up that you can have the same application at different revision points running on different target groups. And we'll see diagrams later about the scenarios in which you would do that. So here you're saying, I actually want to make that happen. Right? So where could you deploy it? Well, it ends up when you start a Datomic Cloud system, you say what application it's supposed to support. You can run more than one Datomic system and say, or compute group, and say they all support the same application. Or each one has its own application. And by default, every new Datomic group will have its own application associated with it. But you can go many to one and one to many. So actually deploying means issuing a command to code deploy to say, I would like to see this revision running in this place. And the choice of places will be known to you. And what's neat about code deploy is that it does not cycle the instance. It informs the agent on the machine, on the EC2 instance, that there's a new revision. There's a whole lifecycle script that happens there, which in our case will cause us to shut down Datomic on the EC2 instance. Go grab that code, pull it locally, and munge the class path to include the stuff from your application, and restart Datomic with your app in the class path. Let's look at that. That looks like this. So you say, I want to deploy. It takes two arguments, which revision and where. And the where has to match, so you can't mismatch this thing. If you don't know where you could deploy, you can just issue the command, and we'll tell you, here are the possible target groups that are ready to be deployment targets of that application. And that goes into code deploy, and it makes something called a deployment, right, which is a record that you asked for this to happen. You asked for this revision to run in this place. That also causes the agent to be notified. What actually happens in code deploy is it's a pull. So the agent is told, you got a new revision. The code in the agent goes and issues the commands to get the new revision of the application. We go and we pull the stuff from S3, the functions, the code, the dependencies, and the configuration. Now it ends up that you might expect to have seen in the S3 bucket some sort of a monolith, right, like an uberjar. And it is actually the design of code deploy that that's what you would be doing. They think that that's probably what you would be doing. I don't like doing that because a lot of that is redundant, right? These dependencies, they aren't different. How many times when you make a new revision of your app do you change all your dependencies? Almost never. Should you have to have put them all in a jar and sent them all around the internet up to S3 and down and back in M2? No. So this system actually knows what's in the M2 on the target instances and only gets from S3 the stuff it doesn't know about. Everything about this is repeatable. All the identities are consistent and reproducible identities. So we end up with the new functions and dependencies and config on the Datomic node. We munge the class path and we restart Datomic. This is a process that you measure in seconds, not minutes, to do this kind of thing. So that sort of is the getting the code inside Datomic. But I talked about connecting to the AWS ecosystem, and it ends up that right now in the current version of Cloud, both to support web services from API Gateway and any of those eventing things, you're going to need Lambdas. So I said you need this config file. One of the things that's in the config file is a declaration that some of your functions, and you wrote many functions, right? Some of the functions are supposed to run in transactions. Some are query functions. Some are just supporting your other functions. But a couple of your functions end up at the edge. Right? They end up being, this is the function you should call when somebody calls this Lambda. That is in your Ion config Eden. And for every Lambda, you designate there. So it basically says, I want to have this function exposed as a Lambda callback. We'll make a Lambda, and we'll wire that up. So that when that Lambda is called, that code is called. And I'll show you how that works in a second. So deployment is not just a code deploy. It actually also creates Lambdas. You use AWS step functions and stuff like that. There's a lot of machinery behind this, and what you need to know about it is you don't want to know all this stuff. So now your stuff is out there. The Lambdas exist, but you're not actually connected to the world yet. If somebody knew about your Lambdas, they could invoke them directly. But there's a step left that's outside of this, outside the scope of what we can do for you, where you have to go and say, okay, let me go to my S3 configuration and say, hey, when somebody puts something in the bucket, call this Lambda, the one that we made for you. Similarly, you may go to API Gateway and say, stand up a new API gateway endpoint, and when requests are made, call this Lambda. So there's configuration associated with doing that. Right now, we don't have any automation around that configuration, but we walk you through how to do it in console. And obviously, you can do the same things from the command line or other automation tooling. So the configuration allows you to sort of make that final connection. We've made Lambdas for you. You're going to sort of connect them to either event sources or to API gateways so stuff can get in. And then you're ready to rock. And you can be invoked. And so we'll just walk through some of the ways that your application can be invoked. I'll start over here, all the way inside. Right? If you've written code and you've designated in the config as being callable, right? Not everything is callable. There's actually an accepted function list, which can be those are the only entry points that you support. The rest of the functions would have to be dependencies. They're supportive code. The first thing is queries and transactions can call your functions. Just use them directly in your query or in your transaction, and you call it. The new syntax we have for that means we'll auto-require and everything else. Nothing you need to do except make a fully qualified function call. The next thing you could do is you can actually directly invoke a Lambda. Some people architect systems with processes calling Lambdas directly. They don't use web services. They just invoke Lambdas. So you can do that. You call the Lambda, and it proxies through. I showed one line of proxying, but essentially all these Lambdas end up hitting your code. And they all work the same way. We wrote a single Lambda once and for all. Call it the ultimate Lambda. We call it Lambda the ultimate. No, it's the ultimate Lambda. We just call it ultimate. It's a proxy. It has no code. It just knows it's configured so that when it gets a request, it knows which group to talk to and which function to invoke. And it just forwards it, gets a response, returns a response. No logic in the Lambda. They all proxy through. The other thing that can happen is stuff can happen in these AWS services, and they generate events. That calls your Lambda, that calls your function. Finally, people use your web service over the web. That hits API gateway, that hits a Lambda, and that hits your function. That's it. That's all your functions. So this is the big picture. which I don't like to show all at once because it's obvious. But the important thing is to look at the left side, right? This is what you do. You do ordinary development of functions in Git using tools deps. You call a function called push. I mean, it really just says push what I've got. And, like we may force you to make a name, but if you have a reproducible thing, we'll name it on the checked out commit. And that's it. That you say push. If you say deploy, you say deploy this revision name to this place. The configuration, like I said, you can do either manually or with automation. The invocation is just, well, like stuff happens in the world, people use your web service. So there's very minimal that you do that is anything other than write functions in Clojure and try them in your REPL, the way you always did. While you're developing, you don't need to deploy anything. You can work against your code locally. You can run the client, as I showed on the very earliest diagrams, and directly talk to the databases. Work in your REPL. You don't need to deploy in order to test. Hopefully that'll be clearer on the pictures later. So, and then of course there's this huge amount of stuff that we do. And this sort of keys you into the other things we've created. We've created this code bucket. We've created these code deploy applications. We've made a relationship between the code deploy applications and the Cori groups so that they are available targets of a code deploy. All that's done automatically. All right. Anybody have any questions about that? I don't think I should move forward. Yeah. They are consistent. It's a function of the name of the target group and the name of the function. So they will be stable. And in fact, we won't make new lambdas unless there's something novel about it. Everything about, I should have repeated the question. It's, do you have repeatable names for the lambdas? And the answer is yes. The lambdas are a function. The names are a function of the designated name and the target group. This is not the strongest part of Lambda. I said it's connective tissue, but like this namespace, I think it's 64 characters. Like, it's not great. And I think AWS, knows this is an area to improve. But it is stable. The other thing I would say sort of overall, this entire architecture is designed to minimize unnecessary work. There's no change, no work. No change in your deps. We don't shovel them around again. We don't make Uber jars. We don't make new lambdas unless something about the lambda configuration has changed. We don't do anything unless there's actual novelty required. So you have high stability. In fact, you add a new lambda, you get no downtime on the other ones. Oh, that's the other critical thing about code deployed deployments. They roll. So it will do this process one machine at a time. So you will get a continuous availability through that deployment. So as long as you're not doing something really crazy like updating in place your functions and things like that, right? This is why I talk about this stuff all the time. It's just the one area that's still left to you, right? The sensibilities about accretion in systems are important, right? If you stick to them, this thing works like a charm. If you say, well, I want this thing to have the same name and do something totally different and take different inputs and return different outputs, you just said, I want to break my system. Let me go do that. Don't do that. Other quick questions, then we'll talk about Cori groups. So the question is, this we've shown here responding to things happening in the outside world. How do you affect the outside world? Well, you could call web services yourself. I mean, it's quite common to make a hierarchy of services calling services. Inside a transaction. No, you can do it inside a query. And you can have an endpoint that's associated with an action. It depends on how you want to sense it, I guess. But no, you can do it anywhere you're running code. So you're running code as a result of a service call through API gateway. You're running code as a result of another event. Unless you have to poll for these things, if you think something interesting happened, say during a query, you can do any number of things. I mean, it's probably best not to try to like synchronously do everything. You could though. You could call another Lambda. You could call another service. You could put something on a queue. You know, all the normal systems topology stuff is available. But you have access to the API, you know, to the AWS API inside your Ions. I mean, you're situated in a node. It's running in a role. You can give that role any permissions you want to do AWS stuff in addition to the things we've given it permission to do in order for Datomic to work. I think the rest of that question is sort of outside of the scope. It's more architectural guidance. One other question on this, and I'll move on. Sorry? There's nothing multi-region about this at the moment. You know, I think AWS is sort of straddling the multi-region thing. They don't fundamentally believe in that, right? They believe in that their regions are units of reliability. But of course, from the very beginning, every customer has asked them for belt and suspenders. I think that idea will become more first class in AWS, and you're starting to see it sort of on an ad hoc basis in some of the services. When it becomes fully first class, we'd certainly look at it. But it ends up that you know, wherever you look in AWS, it's missing the things you need to do that reliably because they don't consider it to be reliable. I mean, essentially, if you want independence between these things, then you don't necessarily know that that's going to be ready to take over when you want to switch. I think in general, that kind of multi-region thing will always be outside the scope of what a service can fully provide because the semantics of transitioning and transitioning back always involve business rules and sort of operational and business integrity concerns that you can't answer for everyone. We don't have any multi-region support built in. All right. So earlier I showed you a picture with query groups on it, and I didn't really explain what they were. And I'm showing you here a bunch of compute groups that could be targets of deployment. We haven't really talked about having more than one compute group, though. But it ends up that in the production topology, oh wait, so here's what you get after you finish this. Your Clojure code's on the nodes. Right? We've added some lambdas for you. They can be wired to services. You have API gateway. I guess I'll tease one future feature because we've been asked for this for a while, and that is it is possible for API gateway to directly invoke Ions if there's a network load balancer available, which there is in the production topology. And in that case, we wouldn't need to go through lambdas from API gateway. So that's something that's on our agenda to do, to be faster and easier to configure and take a hop out of it. So I'm going to walk you through a couple of use cases for query groups. This is something we just released last week. But if you're familiar with Datomic on-prem or have been running Datomic before, this is sort of the moral equivalent of peers. Right? I talked early in the talk about the leverage of immutability and being able to replicate things and get independent querying and independence of applications. Query groups are the way that really becomes real in Datomic Cloud. So the basic problem we're trying to solve is use the leverage we have in being able to replicate data to enable the growth of a system, to have system support more users, to have different applications use the system, have isolation between those applications and how much computational resources they use, and to give them locality for queries, data locality, and working set locality, and things like that. So there are sort of a couple of scenarios, but the basic idea is that once you have a production topology, you can start one or more additional compute groups, and it'll look like the very top part of this initial diagram. You get another auto-scaling group. with instances in it, and a network load balancer associated with it. It can be its own target for code deployed deployments, and therefore for Ion applications. It can have its own scaling. So there are sort of three categories of reasons why you might want to look at this. One is to support multiple applications. I have a web service that I have, and I also have an analytics thing. The analytics thing queries relentlessly, crunches the computer. I don't want that to be running on the same instances as my transactional system at all. So I have different applications. I want to keep them separate. The other reason you might want to do it is for scaling purposes. When you first start with Datomic Cloud, that first compute group, whether it's the solo one or N, is doing everything. Handling transactions, it's doing indexing, and it's handling queries and hosting your ions. At a certain point, you probably want to get queries and ions out of the way of the transactions. In addition, we don't advocate elastically scaling that transactional group because of the way it does caching and the way it has to handle things. That is more of the kind of thing where you're going to say, let's have a meeting and go from 3 to 4. On the other hand, your web apps should be able to scale up and down all day long, elastically. So getting it into a separate query group means you can now set up the scaling on that to be elastic. And the other reason why you might want independent query groups is for different stages of your applications. You want to simultaneously run different revisions of your application. One is in production, one is being tested, one is in staging. Maybe the developers are also doing it. I'll show you some pictures. Start small. The developer is doing stuff. There's a web app. It's getting deployed to the solo. They're also developing against the solo. There may be more databases in there than this says, but and they're all sharing the same instance. There's no query groups here. When you move to the production topology, you have a primary group, and then you may add one or more query groups. So this shows the primary group all the way on the right, and it's still running the application for reals. And then a separate group was set up for CI and a separate one for staging. So we see the developers working on, or most recently committed, revision 55. That's in the set of revisions of the application. This is the code deploy application here. 54 is running in staging. 55 is in CI. And the primary group is running 53. And you have a bunch of choices. I mean, this has some instance sizes on it, but there are a variety of instances available for the different query groups in production. And there's a bunch of databases in storage. This is one storage. This is one system. But there are a bunch of different databases. The developers, you might set up a query group for them. It's only handling queries. It's not actually hosting their code because their code is live on their machines. So this doesn't have a deployed revision on it. It's just answering queries and servicing the databases where you might give every developer a different database so they don't step on each other. So again, you're seeing shared infrastructure in the storage tier, seeing independent groups here. In this case, the groups are only being used for developmental stages. Staging, CI, production, dev, that kind of thing. This is how you would do that. The next thing you might want to do is, as I just said, you might want to get the actual query and ion load off of your transacting and indexing group. Put it on a group that was more elastic. This is a group that will have a minimum of 2, but could go up to 10 during the middle of the day, or whenever it is that you're busy. And now the app is running there, and the primary group is not running an app. It's still serving the transactions. So an important thing to know, and I haven't drawn the arrows on all these diagrams because it gets to be kind of a rat's nest, is transactions always get forwarded to the transacting group. So you may have your app talking to a query group, or your lambdas are wired to a query group, or the query group serving your web. Transactions that hit that group still get forwarded to the transacting group, which does the transacting. If you're familiar with the on-prem architecture, we've replaced the transactor with a cluster. Better from a high availability standpoint. It's easy to configure. There's no heart beating or failover. It's sort of like a live dynamic system for taking over mastership. So this is the app with just the main ions and queries moved off of the primary group. Do this for scaling now, not for staging. And so one of the things that's kind of subtle about this is that all of the apps talk to one transacting group. It handles all the transactions. That means that when you have transaction functions, they're not actually in your app. I mean, you deployed code over here to be your app, but transaction functions are not in your web app because they're not run on those boxes. They're not deployed there. They're run over here. You have to start treating your transaction functions as a shared library to support all of your apps. It actually becomes its own application. It's its own repo. You maintain it. You deploy it independently. That's the first example of another app you might have. Once you get more sophisticated with this, you're probably going to have an independent app for transaction functions. Finally, you may have another app that's for an unrelated purpose. This is what I was talking about earlier, right? You have an analytics app. It runs on one big box. Maybe it doesn't run all the time. Maybe you just run it for an hour a week or something like that. And that's possible in all these cases. You can just set up a CI thing once a day to do that, or however often you want to do it. You can set up the dev Cori group to run during working hours and not the rest of the time, unless somebody asks. And you may run analysis periodically, but not keep that group running. So the important thing here is the sense of independence. Right? These things have independent life cycles. Right? Run it sometimes, run it all the time. You have independent scaling characteristics. You have independent sizes. One of the things that you can have in these Cori groups is you can have SSDs or not, so they have that same kind of local durable caching. They have independence in terms of compute contention. Right? The analytics app is not contending for the same compute resources as the web app. And probably more instances. Have I got this independent? Life cycles, compute, resources. Oh yeah, and working sets. Right? So you have these long-running applications, but maybe the web app uses the catalog all the time, and the analytics app uses the personal data or something like that. Or maybe you have an inventory app that deals with the shipping stuff, which the front-end app never deals with. They'll all start having their own working sets. So they'll all have in their hottest caches in memory stuff that's relevant to what they're doing. Ditto their enduring caches, et cetera, et cetera. That is Cori groups. And I think this is an example of the leverage we get from immutability, being able to replicate all the way to the edges here to get this independent localization, get caching wherever we want it, including this new SSD caching, which really lets you have a huge local cache, much bigger than you could do with like a local mem cache. So to wrap, the point I think with Clojure and with Datomic and with Datomic Cloud and Ions is to maximize your power and your focus. Power is like the ability to get work done. Engineering definition, and it really is the meaning of it. So, I think there's a way to think about this, and it's written out here, right? Clojure is hosted, right? Clojure ran on the JVM. And people could be like, oh, Java, blah, 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 blah. But like, how many people think it's a source of power that Clojure's on the JVM? Or that Clojure script is on the JavaScript ecosystem? Yeah, I mean, it means when you need to do something, you can do it. Because the libraries exist. I mean, obviously, you can make different libraries, but when you need to accomplish something, when you need to do work, you have the power to do it. And I think a way to think about Ions is Datomic being hosted, and therefore your Ions being hosted. What is the leverage of having your application be hosted on AWS, be intimate with AWS? be connected to all of the services, be subject to securing the way AWS things are, being managed the same way with roles, being monitored the same way with CloudWatch and the dashboards and things like that. This is another source of power. It's on a different plane, right? It's a different dimension than sort of like in the app. But it's the same idea. And I think it matters as much or more when you get to the cloud. This is a new execution environment. Right? Just like you need libraries to accomplish things in process, you need services to accomplish things in the cloud. You can't be running data center software up there and expect to get leverage. That's why AWS has all these services. This is how you assemble this power. So this means your code is hosted in the cloud as well as being hosted on the JVM. I do think this really finally helps deliver, even on the cloud, which is a very complex place with a lot of details. It helps you focus on your domain. You really can write Clojure functions that deal with Clojure data on the way in and Clojure data on the way out and not have to think about the rest of this. And I think this makes it kind of categorically different from the many, many things. There are many services that are kind of just like, this makes it easy to do deploys. And it's not really about that. It doesn't let you focus like this. And, you know, we do what we already know how to do. Write functions of data to data, and we test them, and we reason about them, and we use our REPLs and things like that. But it's also easy. We did really work hard to make this easy. So this is simple and easy. That's it. Thanks. Other questions? The question is, are there plans to develop similar integration with other cloud platforms? And the answer is not at present. I do think that there's a pretty big difference between sophistication level of AWS and the others at the moment, but it's a competitive environment. We certainly are hearing requests, so we're receptive to the input there, but we do not have plans at the moment. Something goes wrong inside an ion, how can I debug it? So the first thing is you really do want to test your ions a lot before you deploy them. Right? This is not an environment where you want to let me type it in and then deploy it and then let's see. So hopefully, being functions of data to data, you can do a lot. Like for instance, use spec and things like that. Make sure that it's correct. Now, of course, your ion may do interesting things like call another web service or make an AWS call or things like that. At that point, you're going to want the kinds of things that we needed to make Datomic. In particular, you want to be able to have logging, metrics, and alerts. And one of the things that's included in the Ions API is an API for that. It's called CAST. Essentially, it's a semantic logging thing. It's not like just view this text. But it has semantics that distinguish those characteristics. That you say, I have an ordinary communication I want to make. I have a metric that I want to do, and this routes all the way through to CloudWatch metrics. The others become CloudWatch logs. Alerts will beep somebody, right? They become alerts. And then finally, there's dev spew, which is a thing. And when you're running locally, that will appear, in your local log or in your face. And when you're running for reals, it will disappear at the moment. So those things are all distinguished, and so you have that. So you have, you can catch exceptions, and you can both log and generate alerts and things like that. And you can also, do ordinary messages. So in addition to alerts, we sort of just have like informational messages, which you can do for ordinary lifecycle things, just to see your happy path. And then you have metrics. And then the whole ecosystem around metrics in AWS is pretty rich. You get a very nice dashboard with cloud, and you're ready to go on that. But for your own code, you have those same facilities. Yeah. So the question is it your whole application or just your database layer? Right now, the only host for Ions would be a Datomic thing. So the rest of your app doesn't talk to a database ever. And what does it do? Other parts of your app. Well, I mean, it's hosted on the same machines. It could never call Datomic, I guess. It's not like it's in Datomic as opposed to running on the same instances. So you could just write something that just returns web pages and never calls Datomic in this. Fine. The Datomic part would sort of just be gravy that you're not eating at the moment. But actually, a question for the room, how many people would be interested in Clojure ions that are independent of Datomic? Because I understand sometimes you use different databases, right? So that's an idea that we've had. That's all I'll say about it right at the moment. Which would more directly address that. In other words, all this infrastructure, the same kind of thing, on Marketplace, push a button, you get the whole architecture for using code deploy and driving it with tools depths and all that. Obviously, that makes sense in other contexts. Not something that we've productized yet. Yeah. Updates to Datomic Cloud. The question is, how are they managed? They are managed by a CloudFormation. So depending on what we've changed, you'll do CloudFormation and rolling of CloudFormation. That does mean instance rolling when we change the code of Datomic Cloud. It is the case, however, that the entire infrastructure around Ions loads via Maven through the Ion deploy path, so that is code deployed. When we change the Ion stuff, we don't roll instances. We change database stuff, we do. There are a bunch of settings you can make in CloudFormation when you first start a Datomic process. Some of those you could change later, and they only change as much of the stack as is necessary to reflect the change you made. There's a change to roles or something like that. Yeah. Now the question is, do we have plans to implement something like the Entity API? So the Entity API is lazy, and it's a misfit for remoting. That's why the client API is different. The client API has pull. It's quite powerful. It's not the same, but I like it quite a bit. But we do have legacy customers who, would like things to be similar. The trick there is that's always going to be an anti-pattern over a wire. Use something like the Entity API. I'm reluctant to put it in the client API. The fact of it is, though, when you write for Datomic, so I talked about you're working locally, you're using the client, you are remotely talking to a database to have your queries done, but your code, like your Ion code, is still on your laptop. When you're in that mode, you're using the client. The way you configure the client so you don't have a code change when you go to production is you say that the client is in Ion mode. Ion mode knows I'm on my laptop or I'm in EC2. When that same code runs in EC2, it runs a completely different set of code that is intimate with the database because it's co-residing. It's a lot more like the old peer code. I've heard the requests around this. I've not made a decision yet about doing that because I'm very reluctant to have people start using it over the wire and getting themselves into trouble. Right? I don't believe in pretending remote things are local. Entity API existed because I knew that it was local. Now you could be either. So that's the challenge there. But obviously, if you said, well, I know in dev it's going to be a poor performer and into production it will be good, that's one thing. I'm concerned about people putting that into using clients, which are still available. You may not do everything in Ions, although there aren't a lot of cases where you wouldn't. But if you did start having clients that use the Entity API over wires, that's bad. Yeah. We're leveraging Ions. We're leveraging Ions. Well, we're hosted. We're hosted. No, I doubt that would be anything we would ever do. I mean, I think if we were to do this in Azure or Google, we would probably do it for reals. Yeah. Because that's where the leverage comes. Like if I didn't put anything in front of Java, right? The same idea. It's actually the same idea. I only have one idea, right? Just keep doing the same thing, call it different things, give different talks. But it's because the principles, hopefully they're not changing. That's the idea there. I don't want anything in between. If you're going to be hosted, you want that to be direct, I believe. I've worked with too many portable things that don't believe in it. Yeah. So what you can do, the question is it possible with one application to have multiple Cori groups? You can have an application be deployed to, the same application be deployed to more than one Cori group. Yes, you can. The question is why? I mean, I showed that happening on a couple of these diagrams. In fact, all of these show this green application deployed to more than one group. The reason there was staging, different stages. But my question to you would be, do you have another reason besides that kind of prod versus staging versus CI that you had in mind? Sharding. Yeah, so yeah, you could. And you could do, so the idea is, would you do this for sharding? If you had a way to shard like your user space or something else that you knew you would get locality out of, that would be a big win. Right? That goes to that benefit of isolation, because those independent groups would have their own working sets, and especially the in-memory cache would be highly optimized for the working set. If you could effectively shard, that would be big. Well, that was the first part of that sentence I said, which was if you had a way to partition your work. Right? That's always been true of Datomic, right? With peers, it was the same thing. And my sentence also began with, if you had a way to partition your work that made sense, you would then get locality differences. There is nothing here that's really doing that. We've never, I call that sort of a shard above. And there's systems that shard below, where it's a system's responsibility to shard. That's always mechanical, and the system doesn't understand what you're doing, mostly. Sharding above becomes an application problem. On the other hand, you have a lot of flexibility. So if there's something you can key on there, then you can just say, evens go here and odds go there, and that still works. That doesn't, not a consistent hashing or anything. So yeah. For transactions, that's right. So it could, and I didn't put those diagrams on here. So this keeps going. Okay, so the question is, if I had well, something about testing that was going to like crush from a transaction standpoint, the transacting group, could I get that off of it? Could I split that? And it ends up that you can. I mean, you can go to another system, and there you will now have an independent primary group. And so that's where these diagrams end up. If you look at this on the web, on the documentation, you'll see the last diagrams actually have two independent production groups. And production is completely isolated from dev CI staging. All of that is somewhere else. And that's sort of like a full grown-up, thing. Splits that off. But the beautiful thing is that your applications are accessible account-wide, not just in a system. So that independent system can still be the target of the same applications at different revisions. And that's how you would accomplish that. Get the full isolation of prod. Other questions somewhere? No, we're not. It's not really useful to us because we don't really query it. We pretty much just dump stuff into it, and then later we index that. But we're not going back against it the way that the accelerator would be useful to us. Yeah. I can't hear you. I'm sorry. Could you speak up? Yeah. I don't catch the data structure part. I caught, can you configure it so that your application would have an IAM role for accessing S3? Yeah. So obviously, Datomic ships with a role for these cluster nodes. And they have all the permissions they need to do all the stuff I've talked about. Now your ions may want to do a new thing. Maybe there's another bucket you want to talk to. Or you want to talk to another service that Datomic doesn't use, but you want to use. Or whatever. There's a permissions policy that you can extend, and you can put additional permissions in that policy. And that will be included in the role that the nodes run under. And therefore, you can allow your ions to do more things. It's very cleanly separated, and we tell you where you go to add your own policies. So yes, that's how you do that. That answer the question? Okay, good. Yeah. So the question is, when you deploy, deploy is asynchronous. So you deploy and it returns. And things happen, a couple of things happen. The code deploy has to succeed. Other part, and the question was, what's the other part? The other part is the Lambda creation. That's the two things. So what actually happens when you deploy is not just a code deploy. What we do is we actually create a step function, and that has a state machine that does a code deploy and then deploys each Lambda. That entire thing then becomes atomic. But that's what when we're giving you the status, we're giving you independent status of those two phases. Yeah, all the way back. Which app owns your Datomic schema? No. So there can be many databases. This doesn't actually show an application with an independent database, but you certainly could have completely independent applications and databases, and each application manages its own schema and database. One of the reasons why you see at the bottom here CI staging and prod is because they're all running the same code, but they're running it at different revisions, which means they could be installing different schemas, so they're separate databases. We do allow interaction with AWS Parameter Store, and so we have an ability to go and configure things like database identity based upon a multidimensional set of properties of your groups and your code. So we take those and we form a path. The way Parameter Store works is it's like a hierarchical path. That's how you figure out, well, what database should I be using? That can be independently managed. It's quite nice. So that's how that works, so that each of these things that you see using different databases got to those databases by actually reading the same parts of their config, finding different path segments, forming the same path to what database should Green App use. One gets the answer to the CI/DB, one gets the answer to the staging DB. That's how that works. And if it's not evident, there's a ton of stuff in here, like a ton of things that you don't have to do. A ton. A lot. All right, so an hour and 47 minutes before I got this question. So the question sort of boils down to, what about Lambda cold start? And I think that there's a lot of FUD around Lambda cold start, and then people who have experienced it. And the people who experience Lambda cold start the most often are developers who are sitting around, and they have a brand new thing, and they're like, I want to try this. And they're like, but in practice, you can divide up the real cases, right? So the case is, I have something that's running all the time, that's being used all the time. That thing is warm. Then there's, I have something that responds to events. That thing probably doesn't care. Right? Then there's, I have a human-facing thing that talks to API gateway. It's warm, but I have a request come in that causes me to need to scale. Right? In other words, all my lambdas are busy, and it's going to cold start another one for me. That request is the unlucky request. Partially what you're talking about here, that scenario. So in that scenario, I think it's important to look at the fact that you have two things. It is, I think, not a great part of Lambda that there is one timeout. Timeout governs both how much time does the code have to cold start and how much time can the consuming code wait to get an answer. That's not great because those are semantically two different things. However, once you put API gateway over Lambda, you now have two timeouts. API gateway has its own timeout for responsiveness. Now that's the timeout of the consumer. Lambda's timeout always has to be set high enough to cover your cold start times, unfortunately. So now what happens when you get the bad request, causes a scaling. Well, it causes a scaling event here, but you should have your API gateway set short, right? And it should respond, therefore, with, I timed out. Right? Datomic pushes back through, all the way through your ions, through the ultimate Lambda, through API gateway. If you're going to write a distributed app with elastic resources, you have to deal with back pressure. You have to have something that says, I will retry with exponential backoff when I'm given a timeout. And then what happens? Well, that unlucky person, they had an extra 15 millisecond delay, whatever it was. They did not wait 10 seconds for the cold start. They exponentially backed off and retried. They're going to get their response in tens of milliseconds in the end as they hit a different instance. They can't keep getting unlucky like that. So that's the strategy there. That being said, AWS hears this about Lambda all the time. I'm sure it's a high priority agenda item for them. We're going to do everything we can to optimize Ultimate over time as we get more experience with it. Again, it doesn't do any computation, but it still starts, has to start like everybody else. And then I think that this direct route from API Gateway through the network load balancer directly to your ions is going to trounce everything and make all this go away. And that's why it's likely going to be the next thing we work on, because that's gangbusters. It does require the production topology because that's where you have the network load balancer. So, all right, I think we should probably, yeah, great. Thank you very much.